Welcome, listeners, to another captivating episode of AI Frontiers, where the latest advancements in artificial intelligence and robotics are brought to life. Today, the focus is on Robotics Revolution, Unveiling Tomorrow, featuring insights from 11 groundbreaking papers published on July 5, 2025. Prepare to explore innovations that are shaping autonomous systems and human-robot synergy, from collision avoidance to precision agriculture. Let's embark on this journey into the future of robotics and uncover mind-bending possibilities with real-world impact. Let's dive into what's ahead in this thrilling episode of AI Frontiers. A deep exploration awaits into robotics research from July 5, 2025, highlighting key themes such as safety in dynamic environments, advancements in precision agriculture, and cutting-edge navigation techniques. A special spotlight will be placed on a paper of the day that offers life-saving collision prediction models for autonomous vehicles. Methodologies, jaw-dropping findings, and future directions will also be unpacked. Imagine a world where robots outsmart danger in split seconds. Ready to explore these transformative ideas? Let's set the stage for an unforgettable journey through innovation and possibility, as the latest research paints a vivid picture of tomorrow's technology. To understand the scope of today's discussion, let's start with an overview of computer science. Robotics, often considered the heart of modern automation. This field seamlessly blends hardware and software to create intelligent machines capable of autonomous task execution. By integrating artificial intelligence, sensor technology, and mechanical engineering, robotics enables groundbreaking applications, from self-driving cars navigating busy streets to robotic surgeries in healthcare and even satellite repairs in space exploration. The 11 papers under review today, published on July 5, 2025, address real-world challenges with innovative solutions. Their significance lies in enhancing safety, boosting efficiency, and expanding human potential on a global scale. This foundation sets the tone for the remarkable advancements to be explored, showcasing how robotics continues to redefine industries and everyday life with each new discovery. One of the central themes in today's robotics research is collision avoidance and safety in dynamic environments. The focus here is on teaching robots to anticipate and dodge danger in unpredictable settings, with a particular emphasis on autonomous vehicles. A standout study by Behera and colleagues enhances time-to-collision models specifically for articulated vehicles, such as tractor semi-trailers. Unlike older models that primarily addressed rear-end collisions, this work introduces metrics that also detect sideswipe risks, accounting for vehicle direction and movement dynamics. Tested in simulated environments, these models show immense potential for creating safer highways and supporting the rise of autonomous trucking systems. The real-world impact could be transformative, reducing accident rates and building trust in autonomous technology. This theme underscores the critical role of safety as robotics integrates deeper into high-stakes scenarios like transportation, paving the way for innovations that protect lives. Another compelling theme in current robotics research is precision agriculture, where technology is harnessed to transform farming practices for greater sustainability and efficiency. A notable study by Sayed Asani and colleagues explores the use of virtual reality-controlled robots for targeted disease management in vineyards. Their findings are striking. Robots guided by immersive VR, where operators interact within a three-dimensional simulated world, outperform human operators in treatment speed by an impressive 65%. This approach not only promises scalable farming solutions but also reduces costs and minimizes pesticide overuse, promoting environmental benefits. The potential extends beyond vineyards, offering a blueprint for precision agriculture that could address global food security challenges. This research highlights how robotics can revolutionize traditional industries, blending cutting-edge control systems with practical, real-world applications to create a more sustainable future. The final major theme to highlight is advanced navigation and perception, focusing on how robots can map and move through complex environments with greater intelligence. A remarkable contribution by Lang and colleagues introduces a system that fuses data from LiDAR, inertial sensors, and cameras to create real-time three-dimensional maps, even in challenging conditions like darkness or fog. Their approach leverages a technique known as Gaussian Splatting, which renders detailed 3D scenes from sparse data, ensuring accuracy despite limited sensor input. Applications for this technology are vast, ranging from autonomous vehicles navigating foggy roads to drones operating in confined spaces. This work exemplifies the push toward adaptability, enabling robots to perceive and interact with their surroundings in ways previously unimaginable. As navigation remains a cornerstone of robotic autonomy, such innovations are critical for expanding the operational boundaries of machines in unpredictable real-world settings. Turning now to some of the key findings from this batch of research, it's clear that robotics is actively reshaping the world. Behera and colleagues have developed models that predict sideswipe collisions alongside rear-end risks, marking a significant step forward for road safety in autonomous vehicles. Sayedasani and team demonstrate how virtual reality robots can dramatically boost efficiency in farming, particularly in vineyard disease management. Meanwhile, Lang and colleagues enable precise mapping in sensor-poor environments, enhancing navigation under tough conditions. Other studies push boundaries in areas like humanoid robot balance through coordinated movement and space debris avoidance using predictive algorithms. Collectively, these findings lay the groundwork for safer, smarter automation across diverse domains. They reflect a field not just advancing technically, but also addressing urgent societal needs, from protecting lives on highways to sustaining agriculture and exploring beyond Earth. Behind these impressive breakthroughs lie a variety of methodologies that power innovation in robotics research. Reinforcement learning stands out as a key approach, allowing robots to adapt through trial and error, though it demands substantial data and computational resources. Imitation learning is another method, where robots mimic human behavior for tasks like navigation, but its effectiveness hinges on diverse training examples. Sensor fusion, combining inputs from LiDAR, cameras, and more, creates robust environmental mapping, as seen in studies using Gaussian splatting, yet it requires significant processing power. Deep learning drives complex predictions, such as forecasting space debris trajectories, but its opaque decision-making poses interpretability challenges. Finally, simulation platforms like Carla provide safe testing grounds for scenarios like vehicle collisions, though they often fall short of capturing real-world unpredictability. These tools highlight the ingenuity of researchers in balancing cutting-edge techniques with practical constraints, forming the backbone of the progress seen across these 11 papers and illustrating the diverse strategies shaping the future of robotics. Let's dive deeper into a standout study, selected as the paper of the day. An improved 2D time to collision for articulated vehicles by Behera and colleagues. This research focuses on predicting both sideswipe and rear-end collisions for autonomous trucks, addressing a critical gap in vehicular safety. Its novelty lies in introducing advanced two-dimensional metrics that incorporate vehicle heading and acceleration, moving beyond outdated assumptions of constant speed. Tested in simulated cut-in scenarios, the models not only detect traditional rear-end risks but also flag sideswipe dangers, with the acceleration-based approach excelling in dynamic conditions despite higher computational demands. The potential impact is profound, promising to save lives by enhancing safety in unpredictable traffic environments. This paper was chosen for its representation of a critical leap in vehicular autonomy, fostering trust in technology that could redefine transportation safety for articulated vehicles and beyond, from delivery drones to warehouse robots. Another remarkable paper under the spotlight is Comparative Evaluation of VR-Enabled Robots in Vineyards by Sayedasani and colleagues. This study compares virtual reality-controlled robots against human operators for disease management in farming, with a focus on vineyards. Its innovation lies in immersive VR control, where operators navigate a three-dimensional world to guide robots, resulting in treatment speeds 65% faster than human efforts. Using simulations in Unity and the robot operating system, the research highlights VR robots excelling in precision tasks and navigation efficiency. The impact is a blueprint for scalable, sustainable precision agriculture, reducing costs and environmental footprints. Selected for its real-world applicability, this work showcases the synergy between human intuition and robotic efficiency, with potential extending to disaster response or remote surgeries, illustrating how VR could become as commonplace as traditional tools in agriculture and beyond. The third highlighted paper, Gaussian LIC2. LiDAR Inertial Camera Gaussian Splatting SLAM, by Lang and colleagues, tackles the fundamental challenge of robotic perception through innovative mapping. The focus is on real-time three-dimensional mapping in sensor-poor environments, such as dark or cluttered spaces. By fusing data from LiDAR for distance, inertial sensors for motion, and cameras for visuals, the system employs Gaussian splatting to render detailed scenes from sparse inputs, supported by lightweight depth estimation and optimized computing for speed. Tested on public datasets, it delivers photorealistic maps and precise positioning, outperforming competitors in degraded conditions. The impact spans autonomous vehicles in fog, drones in tight spaces, and even virtual reality content creation. Chosen for redefining robotic perception, this work offers a stepping stone to machines navigating anywhere, anytime, despite challenges like computational strain in large environments, marking a significant advance in universal applicability. Looking toward the future, several critical directions emerge for robotics research. First, bridging the gap between simulation and reality is essential, as many studies rely on virtual tests that don't fully capture real-world chaos like sudden weather changes or human unpredictability. More field trials and hybrid training approaches are needed. Second, optimizing algorithms for lighter hardware must be prioritized to ensure accessibility, making advanced robotics available to smaller entities like startups or rural farmers, not just tech giants. Third, interdisciplinary fusion holds immense potential, with fields like neuroscience offering insights for natural robot movement, materials science for durable designs, and psychology for seamless human-robot collaboration. Finally, ethics and regulation must keep pace, ensuring transparent and safe autonomous decisions in high-stakes areas like driving or space missions. These paths forward blend technical innovation with societal responsibility, highlighting the need for trust and accessibility alongside advancements as robotics continues to evolve. A brief note on the creation of this presentation is in order. This synthesis was developed using advanced AI tools to ensure both efficiency and depth in content delivery. Content generation was supported by GPT-Grok with the Grok 3 model for detailed insights, while text-to-speech synthesis was powered by Google for clear audio output, and images were generated via Grok. Human expert review was conducted to maintain accuracy, though minor oversights may still exist. For transparency, all references are provided, and further details on the discussed papers can be accessed through the arXiv preprint server. This behind-the-scenes look underscores the blend of technology and expertise that brings cutting-edge research to listeners, ensuring a comprehensive exploration of robotics advancements with credibility and clarity. If this exploration of robotics research has sparked curiosity, consider joining the AI Frontiers community for more insights. Subscribe to the YouTube channel titled AI Frontiers, a hub dedicated to the latest in artificial intelligence and robotics. The channel offers in-depth dives into cutting-edge technology, keeping listeners and viewers at the forefront of innovation. Don't miss out. Hit subscribe and turn on notifications to stay updated with every release. Sharing thoughts and engaging with the community is encouraged using the hashtag #AIFrontiers. This invitation extends an opportunity to be part of a growing network of enthusiasts, researchers, and professionals passionate about the transformative power of technology, ensuring that no breakthrough goes unnoticed. As this episode draws to a close, reflection on the future of robotics reveals a field in full bloom, as evidenced by the 11 papers from July 5, 2025. From Behera and colleagues' life-saving collision models to Lang and team's groundbreaking mapping techniques, these works showcase robots evolving not just as tools, but as partners in safeguarding roads, nurturing crops, and exploring uncharted spaces. Challenges persist, including the need for real-world testing and robust ethical frameworks to guide autonomy. Yet, the vision remains clear: robots amplifying human potential by tackling tasks too dangerous or complex for us alone. Listeners are invited to join the conversation on the arXiv preprint server or via hashtag #AIFrontiers. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses content from the arXiv preprint server under its API terms of use. AI Frontiers is not affiliated with or endorsed by the arXiv preprint server.